on, just keep in mind that those videos will be there for you. Hopefully this all works. Mute this. Sweet. All right. So those will be there. Or if you're a person that likes to kind of rewatch lessons or needs to go back and review something, that will be there for you. If you don't feel like using it at all, it's just going to be there and you can just not use it. Also, because of the snow day, everything got pushed back a day. So I'm going to keep kind of changing these dates. One thing I will say is we do need to get this test in on second quarter. If we have more snow days on B days, one thing that may happen, I do want to preserve this review day because of the fact that we're splitting this unit over the break. So if we get a little bit closer to the end of second quarter, we still have another week of buffer. But just in case, I might move section 4.8 to the next unit. But just keep in mind that we will be testing unit 4 in some or all of it before we hit second quarter, the end of second quarter, because I do need another test on this quarter. So I'll keep updating these dates, and I will try to keep updating the dates in Phoenix and on Schoology as well, just keeping that in mind. All right, any questions about resources and or other things? Look at that beautiful thing. So if you're absent and you want to be on the Google Meet, I will not talk to you while you're on the Google Meet, but if you, for some reason, you're like, I would like to attend class live, that's there. And then the videos are here. There's nothing up for AB right now, but I had a couple of BC ones I was working with. It's just a full class, nothing interesting. Woo. All right, you guys ready to do some stuff? No? Did everyone bring their Chromebook today? Or have a neighbor near you that has a Chromebook?
My Chromebook is dead.
All right, before you get out your Chromebook, you don't even have to get it out right now. Here is a picture on the board. Wonderful. This is a picture of kind of like if you were to look up mean value theorem, the thing that we're doing today. This is kind of a picture of what you might see in your textbook. So what I would like you to do, either by yourself or with your neighbor, you don't need your Chromebook right now, just look at the picture on the board. What is one thing you notice about the picture? What is one thing you wonder about the picture? I'm going to give you a couple of minutes. Let me see if I can even get, there's like a little timer in here, I believe. I hope there was
medical experiment.
Whoa, why do I have so many? It's a lot of timers. All right, take 3 minutes with your neighbors. Try to figure out one thing you notice, one thing you wonder. We are going to write some of these down. You're going to want to have something to share out. So think either by yourself or with a neighbor. What is one thing you notice? What is one thing you wonder? It does not have to be a huge thing, but it can be mathematical would be helpful.
Where's the yellow one? Where's the yellow one?
Yellow?
What? White. Bro, I know you did not know shit like that. I wonder.
Hey, did I do attendance? I did not. Is Matt gonna ever come back from the bathroom? No.
Parallel.
One, two, three, four, five, six, seven. Is everyone ready with something? All right, take one more minute. Have something you are willing to share with the class.
What the pink line mean?
What?
What does the pink line mean?
It's labeled.
Or yeah. Like, why is it?
I'm gonna keep touching this and not thinking it's gonna move.
Because you're used to the TV.
Yeah. Well, I didn't really touch the TV though.
How long have you even had the TV? Because it was not that long.
No.
Like
I want to know what they're doing with them.
They're probably selling them. Another broke school system. It doesn't have new things.
Dimmer. All right. 30 seconds. Have something you're willing to say. I'm not making sure. That light's just completely out. Did everyone have a good break, by the way? All right. You guys ready? Everyone stand up. Lift yourselves out of your chairs. Stand up. You may sit down when your table shares something of value. Kirby, what do you notice and or wonder?
Two lines of arrows.
All right. Would you say that's blue?
The blue and the green line.
Blue and the green lines parallel.
It has axes and bends.
All right, Matt, you're saying there are they, I guess they're relative or
Axes
absolute.
and
That's good. We've got some vocab. You guys can sit. Who else notices or wonders something? This table.
I wonder what the equation.
Ooh. What equation might it be? What type of equation do you guys might think? It's a word that starts with P in this case. Parabola. Not really. But parabolas are also another example of them. There's polynomials going on. That might be helpful in the type of function we're working with. Yes.
We wonder what the slope is.
Ooh, okay, so slope. This is gonna be huge today. What do you guys notice or wonder?
Taking marks. Oh, I noticed that there's like a concave and convex.
Ooh, okay, we got some concavity going on, some concave down and maybe some concave up. All right, does anyone notice anything about like what parts of the graph we're looking at? Are we looking at a specific interval of this graph? From where to where? Yeah, we're looking from A to B. Interesting. Cool. Okay, so what we're gonna try to do today. Does anyone know anything about names of these lines, like names of a line that goes through 2 points on the graph versus 1 point on the graph? Cool, we'll start there. All right, in a second, we're going to start investigating this theorem. I'm going to kind of click through this activity before I get you going. You can try it on your phone, but it's probably going to be a little bit more powerful if you have your Chromebook or some sort of computer to work on. If you don't have your Chromebook, feel free to work with a neighbor. What this is going to have you do is it's first going to have you talk about secant lines and tangent lines. Those are the two types of lines that you saw. You're going to sort them once you figure out the definition. And then the idea of parallel, the idea of slope is going to be important. You're going to try to drag this black line until it is parallel to the orange line. You're going to get different graphs where you're trying to do that. It may give you the option to say it's impossible. This is not like a big mathematical thing right now, so don't try to make it super hard. I just want you to, by the end of this, know what is a secant line, what is a tangent line, and try to get an idea of when it's possible to have this black line be parallel to this orange line. If you get to the last two slides, it's going to ask you a little bit about what things do you think are necessary to make that parallel line. So what things about the function, and then kind of ask you a couple of questions going on that slope idea there. So when you are ready, has everyone done something on Desmos before?
Yeah.
All right, when you're ready, it has very clear directions, don't you worry. You're gonna go to student.desmos.com and you're gonna fill in this code. It's a pretty short activity, so I'm gonna see if we can be done. Let's try 5 minutes and then I'll check in. If you don't have a computer and you would like to use one, I can try to see if I can get you to use mine. Or you can work with a neighbor or find someone else. But I think this is super powerful if you can try to do it. So, does anyone need a computer real bad? I'll put me back up. Ta-da. All right. So I'm gonna start with 5 minutes. We'll see where we're at. Does anyone really need a Chromebook? All right. So try to flick through that. I'm going to be asking you about some of the last slides. So like what needs to be true to make sure. Now, I don't need all of these timers. How do I make them go away? There we go. Gosh darn it. Did I typo things?
Yeah.
Excellent.
Now that you are now.
That's what happens when I edit someone else's stuff.
Oh. We should just start plagiarizing straight up. Don't even change it.
There were too many slides on the All right, if you want to see if you sorted them correctly, up on the board. Oh. Yeah.
I'm pretty sure it's correctly, but like for some reason, they're just, well, this one's not like. These are all like.
All right,
Oh,
so.
I think I did.
Does that work? Yeah, perfect. Yeah, sometimes it can do a temperamental. What is this name?
You want me to think about algebra?
Yeah.
It's literally impossible.
So there's two things that we're gonna be looking for, and they're kind of calculus words that we talked about here. So think about, go back to one that you think was like impossible to do. That one's impossible. What do you notice about that graph? Is it not something? That might be a good thing, so you can then need to be continuous. If you have one that works, then it has to be broken.
We only put one in there, Laura. We only put one.
No, I mean, none of these are great. Or maybe I'll just have everyone 5 out of 5.
Do you enjoy your winter? Or your winter?
We traveled a lot.
Really?
So it was a
Where'd you
little,
go?
I mean, not very far anymore, but it was like in a lot of places. We had 3 Christmases.
Dang.
Yeah.
My mom made me drive up.
All right, but we appreciate a little more time to think about this. All right, so some hints for you. I would really love if you could make it to slide number 10 would be a great one to be at. We have some people that have answered it already. But for slide number 10, if you would like some ideas of what to do, you would like to think about, maybe go back to some of the ones that were impossible and think about what was broken about that graph. Was there something that it was not, that if it was, it would guarantee that you could find this parallel line? So some people already have some ideas. I like the idea of continuous. Maybe there's another calculus word that would help me out that maybe this graph is not. And then your last 2 ones would be super helpful as well. So let's take about 5 more minutes. We're not in a rush today. And see how far you can make it. Is everyone like already done? Let's start investigating something. Oh, nice. Yes. Did anyone get the second? Ooh, someone got it. Nice. There was a way I could see all of them at once. Easy.
Man, who said that? Bro, who said that?
Margaret Hamilton.
Trevor's mom?
Mm.
Wait, why is everyone? Oh, it's like an anonymous.
Yeah, they're all mathematicians, actually. Jimmy Escalante.
So.
Oh,
you don't
she's
you don't actually
awesome.
know who Margaret Hamilton is.
It's a mathematician. This is the first female Fields Medal. Pretty
Really?
cool. Yeah. The Fields Medal is like the Nobel Prize for math. I don't know who some of you is.
So when you're on the teacher mode, that's what it says. It just like.
No, I can hide them or not hide them.
Oh. Derivative.
Yeah, it's the J. Oh, I don't know, Margaret. Who would spell it like that?
Ooh, that's Trevor's.
It's a-
I don't know where to put it. But her last name's definitely Hamilton.
All right, let's start to talk some of these out because you guys kind of got the major ideas. So if we look at these, what did we learn about secant lines and tangent lines? Okay, so in the kind of area, secant lines go through 2 points, tangent lines go through 1. Were some of these possible? Was it possible to get this one to have a parallel tangent line? Yeah, it looks like a lot of us did kind of the same line there. This is the original one. How about this one? You got a lot of people were saying impossible. All right, yeah, kind of sucks there. What about this one made it impossible? Did anyone get a word that it was like not this thing? The calculus word for sure. This one was possible though. This was the same graph, right? All right. Oh, so something about derivatives. What's the word for like if I can take a derivative? Differentiable. All right. So it looks like differentiable is important, right? If I have this, why is this part not differentiable? It's a sharp turn, right? So that was causing us some problems. Was this one really frustrating? I did this last year and everyone got super mad because you're like, oh, I got it. Boom. So this one also impossible. Couldn't do this one. What about this graph made it not work? This graph is not continuous. I have this problem where I jump here. So the two things that we needed, I think it was Derek and Ween had this one. All right. So Miss Sylvia Bozeman, whoever that may be, we need our function to be both continuous and differentiable on the interval that we're working with. Because look at this function. Is this function differentiable everywhere? No, it is not. All right. On the interval between those two orange dots, it is. Now, a lot of you answered good stuff about the slope here. If we're finding the slope of our secant line, a lot of people were saying something like rise over run, or like a y2 minus y1 over x2 minus x1. That's going to be our slope. This person even has some actual calculations going on, which is awesome. Tangent lines, you guys were exactly right. We're talking about derivatives. So essentially what seems to be what we're trying to show here is that at some point on the interval, our derivative will equal our average rate of change. All right, fun enough? Would you guys like to play with markers now?
Yeah.
All right, so what I need you to do, I need you to put your Chromebooks away. You will not need them anymore. You don't need to be on that at all. And we are going to attempt to do an activity. After this activity, we will take our break. But essentially what I would like to do is draw some pictures for mean value there. So they're going to be similar pictures to what we just saw. It works better if you're in kind of a larger group. So if you guys would like to join us, you can, or if you just want to do your pairs, whatever. Each group is going to need one long piece of paper. Your group is also going to need 3 markers. There are rules about the markers. So are you ready to listen about the rules? Yeah. One of your markers needs to be either black or gray, background color. The other 2 markers need to be not black or gray, and they need to be different colors from each other. So let me give you some examples. Is this an acceptable combination?
Yes.
Is this an accessible?
No.
No. What's wrong with this?
Too green.
Oh. Could I do this?
Yes.
Could I do this?
No, greater light.
It's no greater light.
Wow.
All right. Hopefully, we understand. Even ones like, this might be iffy. You kind of want contrasting colors here. So,
Purple, orange, and blue.
if you would like, you can send one person up from your table. You're getting 3 markers and 1 long mark. Go. That is the correct spelling of boy.
Remember to the bathroom?
Yes.
What? What do we think? This one's on you.
All right, let's see if we can use our listening skills today. I don't think we can.
Oh, yeah.
All right. You will probably want your desk to be relatively clear. So your desk, Alicia and Black are doing a great job. Their desks are both clear except for their markers. All right, so if you're working just with a partner, this will be relatively easy. You're going to be passing your paper back and forth. If you're working in a larger group, we're going to be passing our paper to the right after each step. So I want to practice passing the paper just to make sure we can do it. So whoever has the paper first, can you claim it and put it on your desk for a second? You're not doing anything right now. We're just practicing passing the paper. So when I say go, you're going to pass your paper to the right or to your partner if you're working in a pair. Ready, go. Just pass your paper to the right. All right, let's practice one more time. Go.
Go.
Practice one more time. Go. All right, practice one more time. Go. All right, now, the person who is going to start with the paper is going to draw on it. So if you are feeling nervous, the first thing to draw is not difficult, but if you're feeling nervous, you don't have to go first. All right, should we wait for Sadie to get that? I will tell you. So, things that need to happen for this activity. 1, the directions are going to be verbal. I will say them multiple times. I will say them many times upon request, but I'm not going to be writing them down. So it'd be helpful if you were listening. There are a lot of directions. Every time you're going to be drawing something, what you'll need to listen to is what color you're drawing it in and what you should be drawing. I can help if you want. If you're nervous before you write down, I will help you. Hopefully we'll have some good pictures. Are we ready?
Yes.
All right, person number 1 should have the paper and your neutral colored marker. That's black or gray. All right, before you draw anything, listen to the directions, ask any clarifying questions. I would like you to draw the X and Y axis. I would like you to not draw any scale. We are going to be filling the whole paper, so make it big. It doesn't matter if your X goes like hot dog and your Y goes hamburger, but fill up the whole graph with your X and Y axis. So ideally, you're going doot, doot.
You want to label them?
You can label them if you would like to, but you don't have to. You're drawing your X and Y axis. I will also be walking around at points and picking up good examples. So way to go, there's an X and Y axis. Wow, beautiful. All right. Are you ready? Does everyone have their X and Y axis? You may label them if you'd like, or you can just leave them. You can always change your mind and switch it. All right. We're good. Actually, still going. When your markers are not in use, tap them. All right. In a second is going to be the most stressful part. So hopefully the person getting the paper next is not stressed.
Are you stressed?
It involves the most choices. All right, pass your paper to the person drawing next. I have a hair in my mouth. All right, I'm going to clarify a lot. My recommendation, I would go long ways with your paper. It'll make it easier than if it's taller. So Wayne and I might rotate. All right, the next person needs the neutral colored marker. So Wayne, great job. You have the gray marker. Wonderful. Everyone else has the black marker. All right, I'm going to tell you some instructions, so don't draw anything yet. This is going to be a thing where you're going to want to use a lot of space on the graph. Your directions, person number 2, are to draw a function. The only requirement is that your function passes the vertical line test. So we can't do like loop-de-loops and stuff. You need to pass the vertical line test. I did not say your function has to be continuous. I did not say your function has to be differentiable. Please don't make your function too crazy because you're going to kind of make yourself angry. Guys, are we listening? Doesn't sound like it. All right, I wouldn't make your function too crazy, but I would also, please don't draw a line. A big parabola would be like the most boring example. I would love if like maybe someone could do something that's not continuous, someone could do something that's not differentiable. If you're not feeling brave, just draw something that's very polynomial. So whoever's drawing, I want you to use your whole graph to draw a function with your neutral colored marker. If you are nervous, ask your group for help or ask me for help. I'm going to give you a minute and a half to have your function drawn.
We're not going to complain. Do whatever you want.
Wonderful. Here's a great example. It's not too complicated, but it's got some interesting stuff happening. Yours doesn't have to be as complicated. Nice. Nice. You have a little bit more like wonderful. All right. Everyone got their function drawn? Pass your paper to the right. All right. The person that has the paper now gets to choose one of the two colored markers. All right. Are we ready? All right. Hold up the marker that you're going to use if you're drawing. Good. All right. You are going, person with the marker that is colored and not black or gray. You are going to draw a point somewhere towards the left side of your graph. It doesn't have to be all the way to the left, but have some room on the right-hand side of it. On the function, yes, that's a good clarifying question. I want this point to be on the function. I want you to, after you draw that point, I want you to label this point with an x value A and the y value f of A. So you are going to draw a point on the function somewhere on the left side of your graph. I want you to label that point A, comma, f of A. Let's see who's going to get that. Great. A, F of A. A, F of A. All right. Pass the paper to the right. All right. You need the same color. The same color the person just used. So if the person before you used pink, you need pink. You are going to draw a second point somewhere towards the right side of your graph. It can be close to the last point. It just needs to be to the right of it, somewhere to the right. Any point on the function, somewhere to the right, I want you to label that point, surprise, surprise, B, F of B.
Oh my god.
All right?
Cool.
So a point somewhere slightly to the right,
Oh, wait, all the way on the other side?
doesn't matter, just needs to be somewhere to the right of it. B, F of B. Great example. Lovely. Ooh, that's gonna be interesting. I like yours.
I'm thinking, hello, you should try it sometime.
All right, are we ready?
Literally infinite points that I could pick.
Are we ready?
Almost. Should I not draw on the same straight line? That's a weird looking
All right, are we ready?
You're
All right, pass your paper to the right. You can also pass the marker. You need the same color one. All right, in a second, the person is going to use that same colored marker to draw a secant line. What do you think the secant line is going to do to those 2 points? It's going to go right through them. If you would like a ruler, I'm going to drop off a ruler. I would think it's pretty long. So don't necessarily just connect them. I would go through both of the caps.
It was like.
Go beyond that.
I would go beyond.
Are you supposed to draw a secant line? Isn't the line they're on already the secant line? For hours?
That would, interesting, yeah. So your picture's gonna be really good. So that's cool. I like it.
We love it. You like it?
You're gonna, you can make it look like you want.
Get started on my team. So it's like.
Ooh, are you predicting that? Good at predicting directions. Hold on it though. All right. Can we show off our secant line? Beautiful secant line. Wow. All right, we got an interesting thing going here.
So if you find 2 or more points or just. But then ours isn't it?
Yeah, so yours is definitely B.
All
right.
That one's touching. There's still a third.
Yeah, so we can, this one's kind of like doing an average rate of change here instead of, we'll talk about. No, you're first. What I'm asking Another very good example. All right, we are all ready. So next set of examples is the kind of moat. All right, are we ready? All right, somewhere in an open space on your graph. So let me give you an example. On this graph, I might start writing like up in this general area. We're gonna write an equation. We're only gonna write one side of it right now. If you wanna check with me before you write this part down, you can. So this is still in color number 1. What you're going to write down. What you're going to write down is you're going to use your Algebra 1 skills to write down the slope of the secant line that you drew. No, I don't want you to write like rise over run. I want you to use the points that we labeled.
The y line one?
That would be a great thing. So y2 minus y1, but I wouldn't write y2 and y1 because I have two y values. So I would write down the slope of the secant line somewhere in there. You're probably gonna write a fraction somewhere. But instead of y2, what do you write? You don't have to write a fraction. All right, does everyone know what they're gonna be writing? Anyone got some ideas? You guys want to do this part together? Oh, I don't need to write with that one. All right, so let's say, try to write with this. All right, what did you guys say about slope? All right, let's try that. I want to write, give this to me. All right, it won't. All right, so we're doing rise over run. This is not what we're writing. Ooh, there we go. What's the difference between my two y values? What y values do you have? F of b and f of a. What two x values do you have? That is what you should be writing down.
Can we just write 0?
No. General.
Right. Still right. Just fix it down. Just fix it down. Just next to it.
All right. Are we ready?
Sure.
All right. Pass your paper. The new person needs the new color marker. All right. This one is the most complicated, so I would listen with your big boy, girl, non-binary. Are we ready? Now, this may be impossible for you. Looking around, I think it's possible for almost everyone, but it may be impossible.
It's possible.
Thank you so much. What you're going to do, I want you to find a point between the 2 points that you found, that you drew, where the slope of the tangent line equals the slope of the secant line. I want you, before you draw it, point at it and get confirmation from your team. All right? If your team agrees, you can draw this point and label it C, F of C. So again, you want to find a point between the 2 points you drew.
Can we draw the line too?
You're stealing work from the next person, but.
Why?
So think about, you want this. You're trying
How can you pick red? No, I feel like orange. Yellow, green. We're gonna send you again. We're gonna send you again.
Alright, so you have this one right here. I want you to find one point on this graph, but if I move this ruler to kind of keep it parallel, where the tangent line would be parallel to this. Yeah, you really kind of have a lot of points depending on how you're trying. Kind of got to weed down here, somewhere in there is probably.
No.
It's fine. It's fine.
Tangent line number shares.
Oh, yeah, no, oh, once you imagine.
All right. You guys all have a point? All right, can we put the phones away, please? Thank you. All right. Everyone have a point?
Yeah.
Did everyone label their point? What is it supposed to be labeled? C, F of C. All right, once you have that point, You can pass it or the same person can do it. I don't really care. Do your best to draw that tangent line. So the one that we said was parallel to the secant line, do your best to draw that line. If you already have it done, just hold for a second.
Cause it worked. Just because you're not quirky like I am.
All right. All right. Are we ready for the kind of last and final step? All right. Can anyone remind me, as we're kind of drawing, can anyone remind me, for parallel lines, what's true about their slope? Parallel lines, what's true about their slope? It's the same. What's another math word for the same? Equal. So I want to have something be equal to this fraction that you put down. Now, how do we find slopes of tangent lines in calculus? Derivative, all right? Let's say our function is labeled f of x, because it is. What does the derivative of f of x look like? F prime, and what value are we going to be plugging in? C. All right, so I want you to finish with your second color. I want you to finish this equation. You've got your fraction equals your derivative at your C value. If you're feeling so artistically inclined in some open space, you could write down mean value theorem, or MV. All right, was everyone able to draw theirs?
We just said equal to
Yep. All right. Everyone got a picture?
Wait, you have to rewrite like this slope and then say equal to.
All right. Everyone like their picture?
Yeah, it's great.
Like, does anyone think they could have found more than 1 point where this would work?
Yeah.
Yeah.
Infinite points.
All right, so one thing I want to tell you about mean value theorem. One thing I want to tell you. Do you guys remember another theorem we did earlier this year? Intermediate value theorem. This is another one like that where this is called an existence theorem. It tells us that something happens, but it doesn't guarantee how many times or where. So what we're going to be doing in a second is we're going to be using this theorem to say, hey, this happens at least one time. What had to be true about our function to make sure this would work? It had to be two things. Continuous. Now I want to point out, I actually like this graph a lot. On this graph, they were able to find their parallel line, but we weren't differentiable here. So were they actually guaranteed that they could find this line? No. One of these graphs, you were guaranteed definitely to find that line, and that would be this guy right here. Risha and Milan drew a graph that is very continuous, very differentiable. So no matter what 2 points they chose, they were going to be able to find this line. Some people had a good example. This graph had some places where we were discontinuous, not differentiable right here, but it wasn't on the interval, so they were fine there. They were guaranteed. All right, would anyone like to hang up their picture?
Yes.
All right, let's make a montage over here. So I'm gonna give you a couple pieces. If you would like to pay your bill, what do you do? You can also return your material.
Wait, you guys didn't even write Theorem. It's not continuous.
It doesn't have.
Right? She said it does, bro.
I was referred on that wall, like the other one. Where were you going with it? All right. What we're gonna do when we come back from our break. So all of this is kind of motivating what mean value theorem is. When we come back from break, I'm gonna be mostly showing you how you're going to be asked questions about this. Because it's a little more aggressive once we actually get to the questions. So let's go ahead and take a solid break because I know it's hard to listen on the first day back from break. Not 10 minutes. Let's go with 4. Yeah, I know.
That's like less than.
All right. So take a break. If you need to go to the bathroom, that's fine. If you want to return any materials you have, now would be a great time.
Yeah, we put the markers back.
What they're saying now. Beautiful. I think your guys' is my favorite today.
Is there a nice value theorem?
box.
No. All right. Materials. That's interesting that everyone was able to do this. Usually there's at least one person who can't. I want to figure out how to, why won't it let me write it?
Oh.
Oh my goodness, it is warming.
That's not the psychological.
Yeah, what's the vibe on this snow? 2 to 4? Oh, I heard 1 to 3.
Yeah, I heard 2 to 4.
I haven't checked in a hot second then.
Then on Thursday, on Sunday, we're getting a good amount.
Wow. All right.
I really want to have,
Wow, Xander. Okay. I'm sorry. Sorry for a quarter of that. Usually people would say, Matt, usually people say, no, I like your class a lot. You're like, no, it's okay. I hate your class. All right. All right, so let's make everyone hate my class. Let's go ahead and let's talk about mean value theorem. So if you were not paying attention up to this point in time, now is the time to start because I'm going to show you what kinds of questions we're actually going to have to be able to do. So our mean value theorem, as you could see it in a textbook, is as is presented up here. So we have a function f. It has to be two things. This is going to be another case where we have to observe but not prove that these things are true. We need to have a continuous and differentiable function. Herbie, if you could not talk while I'm talking, that would be great. This is an upgrade from IVT. For intermediate value theorem, we only needed a continuous function. Since we're talking about f prime in this case, we're going to want a differentiable function as well. So we need both of those things to be true. What we're guaranteeing is that at some point C between A and B, so just like that point you drew between those 2 points that we drew in the beginning, we are guaranteeing that f prime, our instantaneous rate of change, is equal to f of b minus f of a over b minus a, our average rate of change. There's actually a really good real world example of this. Has anyone driven on a highway and seen the speed enforced by aircraft things? And have you ever wondered, like, how does that happen? What they actually do is there's usually like those big, long white lines that go all the way across the roadway. And what that aircraft would do is they would measure how fast you went between those two lines. So they'd be finding your average rate of change, like here. So they might find your change in distance over change in time. So change in distance being the top, change in time being the bottom. And what they can prove, since you drive in a way that's continuous, you don't like teleport between places, and you drive in a way that's differentiable, your speed doesn't suddenly change, you kind of smoothly go between speeds, is that at some point, if I went an average of 45 miles per hour, at some point I had to be going exactly 45 miles an hour. They do this on toll roads too, to the point where they actually build restaurants between toll booths so people can speed, stop and eat, and then speed some more. So this is your instantaneous rate of change. So let's practice a couple of types of questions with this. There's a couple of ways we can kind of do these questions. The most popular of which is going to be, hey, here's this function, or here's this table, here's this graph. Can you show me that there is a point in this interval where the average rate of change equals the instantaneous rate of change? So we're going to do a couple of these. That's kind of the most popular. Kind of like with intermediate value theorem too, you're going to notice that we don't often actually find this value. Sometimes we can, and we're going to do that in this question, but that's usually not the case. So what we're going to do is this first sentence first. We have this function 5 minus 4 over x. We're going to show that there is a point C in the interval 1 to 4 where the average rate of change equals the instantaneous rate of change. So what's that? No, that's a comma for the sentence. Yep, good ask though. All right, so let's first find this average rate of change. So I'm going to find f of something minus f of something over something minus something. What do you think those two somethings will be? What x values? 4 and 1. And I like the order that Herbie said that, 4 and 1. If you swap them, it's okay. You just have to swap on top and on bottom. So f of 1 minus f of 4 over 1 minus 4 would also be equivalent. I usually like to go from high to low though. All right, how do we find f of 4? Yeah, plug it in. So I'm going to do 5 minus 4 over 4 is 1. 5 minus 4 over 1. That's 4. All right, I'm just going to keep simplifying. So I've got 5 minus 1 is 4. 5 minus 4 is 1. On the bottom, I'll simplify to 3. This looks like 3 over 3 or 1. Now, a lot of times in these problems, once we get past this kind of first page of notes, you're going to notice that a lot of the time we're given this number. So we'll say like, find where f prime of x would equal 1. So a lot of the time we'll be matching that number. All right. We also need to know something about the function. So the function f. Anyone know what 5 minus 4 over x looks like? Should we look at it? All right. So we're going to do this with Desmos for a second, but we're going to also talk about how we could know this without a calculator. So I'm just going to graph 5 minus 4 over x. All right. Here's this guy. All right. So that's the whole graph. It does have an asymptote. Where is that asymptote? 0, x equals 0. So do I really care about that asymptote a whole lot in the context of this question? Where did I care about this function? All right. So there's the piece of the function I care about. On this piece, does that piece look continuous? Does that piece look continuous? Yeah, it does. Does it look differentiable? Are there any like sharp turns? No, it looks fine. How could I do that without a calculator though? Really the only problem part of this graph that I see is the division part, the over x right there. The only piece of the function that's kind of producing any discontinuities or places where there would be problems with the derivative is the bottom of that fraction, and I can see that that place is x equals 0. So I can kind of be okay with this function. What we're going to do is we don't have to prove that this is continuous and differentiable. We just have to observe it. So we're going to say f is continuous and differentiable. And I'm going to make sure I say my interval here because it's not continuous and differentiable everywhere. So I'm going to say from x equals 1 to x equals 4. You could also say on the interval 1 to 4, whatever you want. I just need to make sure that I know that this is true. All right, so we've got a continuous and differentiable function, and we've shown what our average rate of change is. Those are going to be kind of our 2 steps. And then we're going to write our conclusion sentence. So we're going to say by mean value theorem, or in this case, MVT. And this is another instance where you can kind of plagiarize the sentence. We're going to say there is a C between 1 and 4 where I could say our average rate of change equals the instantaneous rate of change. What I'm going to say is f prime of C equals the 1 that we got. This is going to be what we're asked most of the time. Most of the time, we're going to have to say our f is continuous and differentiable. That may be given in the problem. We may have to kind of decipher it a little bit like we did here. We're most of the time going to find that average rate of change. We may match it to what's in the problem, or we may just have to find it like here, and we're going to write some sort of conclusion, hopefully mentioning our theorem. Now, this question has another piece to it, which is not usually there. This part says find the value of C. Well, we're trying to find the value of C where f prime of C equals 1. Could we find what f prime of x is here? You guys remember how to take derivatives? I know it's been like a whole year.
Yeah.
All right. Yeah, let's rewrite this function. How could I rewrite minus 4 over x if I wanted to rewrite that with an exponent right here? If I brought that x up. Yeah, let's do a -1. All right. And let's find f prime of x. What's the derivative of 5? 0. And then how do I take the derivative of -4x to the -1? All right, so Herbie brought down that -1 times the -4 is 4. And then how did he get -2? Subtracted 1. And I'm claiming that at some point, this is equal to 1. All right, let's figure out how to solve this. What did we say about negative exponents? Where do they come from? The bottom. So let's move this x to the -2 back to the bottom. And how would you guys solve that? 4 over x squared equals 1. Okay. So 4 equals x squared. X equals 2 or... All right, but technically only one of those is right. Anyone know which one is the one we're looking for? Why positive 2? It's in the interval. So we have x equals... All right, the only other type of question that we get asked about is about the conditions we need for mean value theorem. So here is our last type of question, and then we'll practice some that are actually from AP tests. I want to explain why the functions that are right here, we have 2 examples, do not satisfy the conditions of the mean value theorem. Really, we had 2 conditions about our function. What were those 2 conditions? Continuous and differentiable. So looking at f of x, which is this absolute value guy, what's the problem with him? Where? Let's give an x value. Perfect. So because this function is not differentiable at x equals 0, which is on this interval that they're talking about, mean value theorem doesn't guarantee that I can draw this line where they're parallel, my average rate of change equals my instantaneous. I might be able to, depending on the 2 points that I choose, but like on this one, -2 to 2, there's not going to be a parallel change line there. All right, what's the problem with g of x? Not continuous, where? Perfect. All right, so again, if I draw my -2 somewhere down here up to 2, for this one, I may be able to draw that line. It actually looks like I could draw something right there, but I'm not guaranteed that I am able to do that. So you might have a condition where you can, but you're not guaranteed by the mean value. All right, let's try to do, I think we can do these 2 questions and then we'll be done for today. We'll kind of revisit some of those dates. So this is a very, very popular type of question for the free response on the AP test. And remember, when I say free response, you're talking one context for the question and then parts like A through C, maybe A through D, A through E. This is a very popular one. So here's one from 2017, relatively recent, but there's one pretty much every year on the exam. So let's talk about parts of the question that tell us what we're doing and then what we have to do. So we have a function, g of x, we're told it's differentiable, and we have a table of both g of x and g prime of x. I want to know, is there a number c in the closed interval -5 to 3 such that g prime of c equals -4? And we're going to justify our answer. So again, the kind of words we're looking for are, is there this x value? That's very similar to IVT, where we're getting this like, does this thing exist? The difference with IVT and MVT, and we're going to probably practice this in the next couple of days, is here we're being asked for a derivative existing versus a y value existing. IVT is all about y values, MVT all about derivatives. So I'm going to look at this table, but I'm going to look at very specific parts of it. What 2 values of x am I really interested in this problem? -5 and -3. I'm really caring about those 2. All right. What should we do first? Is there anything we need to know about our function? There's 2 things. Perfect. Is this function differentiable? What do you think? Let's read the paragraph. There's a differentiable function g of x. So is it differentiable? Yeah. So we're going to observe that for them. We're going to say g is differentiable. They told us. Sweet. in general, if you ever think you need more information, look at the paragraph they wrote you. All right, is G continuous? They didn't tell us outright. Is it continuous? How do I know? All right, if something's differentiable, it's always continuous. So since G is differentiable, G is continuous. And that's going to be a really popular way for them to disseminate that information to you. They're going to tell you your function is differentiable. You have to provide, hey, that means I'm continuous. All right, then what we're going to do, we're going to find our average rate of change. That's going to look like a fraction. What's the top going to look like? Hello?
Is it like negative, what is it?
Mm-hmm. Perfect. I'm going to switch those to G's because my function's labeled G. And I'm personally, you could do it in the order Matt's doing it. I like to go from biggest to smallest number. So I'm going to go -3 to -5. Just make sure you're reflecting whatever that is on the bottom. So keep in mind that this is G of something on the top. So I actually don't need this G prime column at all. So I'm going to be doing G of -3 from the table, that is 2, minus G of -5, that is 10, over 2. You could simplify all the way. I was going to simplify halfway and just do the adding first. All right. 2 minus 10 is -8. The bottom is 2. So I get the number -4. Does anyone see that number in the problem? Yes. You should get that number. I don't think I've ever seen a question like this where they're like, is there a number C? And the answer is no. It's almost always, I will go as far to say pretty much always, yes, it is the case. And you should be getting this number. If you don't get that number, you may have to go into an IVT situation or do something creative, but you should be getting that number. All right. So we just need to answer the question now. So is there a number C? Yes. All right. We are going to say by MVT, there is a C between -5 and -3, where G prime of C equals -4. Now, the end of that sentence can look as formal as or as informal as you want. I usually just paraphrase the sentence, but if you want to straight up plagiarize it, that's fine. You could say there is a number C in the closed interval -5 to -3 such that G prime of C equals -4. I like to paraphrase a little because I don't like to write that much, but whatever you would like to do. All right, to finish up class today, I want you guys to try one of these on your own. So this is another one that's very similar in nature, a little bit older, so from 2013, but again, there's kind of one of these every year. So you have hot water dripping through a coffee maker. I want you to follow the same steps to try to see, is there a time between 2 and 4 at which C prime of T equals 2? We're going to go over it. So take about the next, 5 minutes if you need that long. I might kind of walk around if you need any assistance. So you're trying that one at the top. So your phone should not be out. I'm going to start taking all stops. Can't handle it. right, you ready? Everyone done? Who's hating me because we did that?
No.
All right.
Very good.
All right, what should we write first? Oh, C is differentiable, which also means? Perfect. All right, what next? So what up? All right, did anyone do it in that direction, C of 2 minus C of 4? Okay, either one's fine. You just have to make sure you have the same direction on the bottom. I'm going to go 4 to 2 just because that's the way I like to do it, but you're more than welcome to do it the other way. What was C of 4 from the table? 12.8. And then C of 2, I think 8.8. So although there are decimals, not scary, 0.8 minus 0.8, that's no decimals left over. I get 4 over 2 or 2. Am I surprised to see the number 2? No, it's right there. And it should be right there. If you're not getting that number, check your arithmetic. Am I done? No. All right, I'm going to plagiarize this question to turn it into my sentence, and I'm going to add in the theorem name, which I can use mean value theorem or MVT. I'm going to say there is a time t between 2 and 4 where c prime of t equals 2. All right, to finish up, let's look at one multiple choice question because I think this one is cute. And then I promise I will stop talking to you. Can you look at the middle one on the back page just to really get with the idea of what we're trying to do? So think back to the pictures that we drew. I want you to read this question. This was off recent AP practice questions. So I need to read that middle multiple choice and see if you can pick the point and or points where mean value theorem can be applied. Now this function is continuous and differentiable on the interval they're showing us, so you should be able to find some points. I'm going to try to answer that middle question. It's a lot of reading though. Where did my timer go? It's gone. Oh, there it is. What are you doing, Susie? In 1 minute, I would like you to have an answer that you're willing to go forward. I know there's a lot of stuff. Honestly, I didn't read the question. I just looked at the picture. All right, do you have an answer? All right, I'm going to start reading. We have the function f shown in the figure. It's continuous from 0 to 12. It is differentiable from 0 to 12. Is it C?
That's my vote.
Does anyone else want to vote for C like Herbie? All right, I actually agree with you guys. I drew a red line. Let's review some vocab. What line is that? The secant line. It goes through 2 points. Now, you guys chose 2 and 9. So 2 is here, 9 is about here. What made those work out in this problem? The tangent lines were what? I heard it back there. parallel, so their slopes were equal. My average equaled my instantaneous. All right, perfect. Thank you guys so much. I know the first day back from break, especially with some snow days, can be a challenging one to pay attention. So again, just to review some schedule stuff, we are now done mean value theorem. The next couple of classes, hey, y'all. The next couple of classes, we have some shorter lessons to do. Next class, particularly second derivative test, is not very long. So we're going to take a second to go back and review some of the things we did before break. Then 4.7, we're going to really focus on using the calculator to do some of that. What? Second derivative test is like a test to find thing. So it's not an assessment. It's a way to find maxes and mins. And then barring any snow disasters, optimization is like the related rates of this chapter, where we're going to be doing some word problems, but not as challenging as related rates. So it's kind of the next 3 days, but I'm going to try to build in beginning of class activities to review this stuff before break. Keep in mind your problem set is going to be due on this review day. I will be bringing alternate materials to help review, but that's a good day to do some of the problem set. Just make sure you're kind of working on that as well. All right. I'm going to shut up now. You guys have about 2 minutes to do whatever you'd like. Thank you for being here. Maybe I'll see you on Friday. You guys know how to make me feel so sad.